Hi guys, welcome back to another video. Today we're going to be talking about completing the square, which is a really important part of A-level maths. So what is completing the square? Well, all it really is just a way of manipulating a quadratic expression into this useful form. So if we had x squared plus bx plus c, if we were to complete the square on that, it would just mean putting it in the form of x plus some constant, we could call it h squared, plus another constant, for let's say for this sake we'll call it k. And this form here is really important, particularly in things like finding maxima and minima, and also it can be used to solve quadratic equations. So I think it's best if we jump into an example straight away. So if we had x squared plus 2x minus 4, how would we get that into a form of x plus h squared plus k? And it might not seem entirely obvious at first glance how you do this. But what we can consider, for example, is what would happen if we had our x plus h squared and we expanded that. So we know that's the same as doing x plus h multiplied by x plus h. And if we just use our technique for expanding brackets, you should be able to see that that would equate to x squared plus hx plus hx plus h squared, which is x squared plus 2hx plus h squared. And so if we just consider these first two terms of that expansion, you can see that looks pretty similar to the first two terms of our example here, x squared plus 2x. And in that case, or in the case of our example, we could say that h is effectively equal to 1. So what we might like to try, for example, is what would happen if we did x plus 1 squared. And using our same method of expansion as before, you should be able to see that that's equal to x squared plus 2x plus 1. And you can see that that's very close to what we want to achieve in our example, except for the fact that in our case we have a plus 1 here, and what we really want to achieve is a negative 4. So how would we go about manipulating this so that we get our desired expression? Well, first of all, we want to get rid of this positive 1. So we could take 1 from both sides. And then we want to add on this negative 4. So we could also take 4 from both sides. And you should be able to see then that on the right hand side we'd get x squared plus 2x. And then the plus 1 here and the negative 1 would cancel, leaving us just with negative 4. Which is what we wanted to get. And then on the right hand side we now have a bracket in terms of x, all squared, and then if we add minus 4 to minus 1 we get minus 5. And as you can see here now, we've successfully completed the square. So we have x squared plus 2x minus 4 is equal to x plus 1 all squared minus 5. So over time you'll find you become more comfortable with how completing the square works, and you'll just be able to start seeing patterns. So what will always be the case is that when you have x squared plus a constant times x plus another constant, in this case it's negative 4, you'll see that your bracketed term will always be x plus and then half of this constant in front of the x. So if this was a more general expression, like x squared plus a x plus b, completing the square would always take the form of x plus a over 2 all squared. And then how would we obtain the constant that comes after it? Well, we want to think about the constant we don't want that comes from the expansion of this bracket. So remember, if we expand this bracket, we'd get x squared plus ax plus a squared over 4 from multiplying the two a over 2's together, which is not what we want because we want this constant b. So to get from that to b, we want to take away our a squared over 4 and add our constant b. So coming back to the expression in our equation here, we want to take away a squared over 4 and add b. So this is kind of like the general form for completing the square. So you identify what this constant is in front of your x, and then take away the half of that constant squared, and then add on this constant b. So another example could be, maybe to make it perhaps slightly more difficult, if we had a negative sign in front of our x. So we might have negative x squared plus 3x minus 6. Now I think with a negative sign particularly, it's easiest if we just try and eliminate that to start with. So we take that out of the bracket completely. So we could do negative, and then all in brackets, x squared minus 3x plus 6. And you should be able to see these two expressions are consistent. So then it becomes a simple case of completing the square again. So using the same method as we used before now, we can keep everything multiplied by this negative sign and just apply our rules for completing the square. So we know again our first bracket we want to try is x minus 3 over 2 all squared, and we know that that's going to give us this first part. And then we want to take away our unwanted constant that comes from the product of two of these 3 over 2's, which would be 9 over 4. And then we want to add the actual constant we want, which is plus 6. So if you were to type that into your calculator, then it would get minus x minus 3 over 2 all squared, and then minus 9 over 4 plus 6 would give you 15 over 4. And then we could multiply this all through by the negative sign if you like, so we'd get minus x minus 3 over 2 all squared minus 15 over 4. So that was an example where we had a negative sign in front of our x squared, which might have made things a bit more tricky. But we can also get cases where we have a constant in front of our x squared. So we might have 3x squared plus 12x plus 27, for example. So how would we complete the square on this then? Well, we could either take 3 out of our entire expression, in which case we'd get 3 multiplied through by x squared plus 4x plus 9. Or perhaps in some cases it might be easier, although a bit more prone to mistakes maybe, but we could just do that to the part that we want in brackets. So we could say that's equal to 3 lots of x squared plus 4x, and then plus 27. And then we can evaluate this bracket here, or complete the square on that bracket alone. So in that case we get 3 lots of x plus half of 4, which is 2, all squared. Take away our unwanted constant, which is 4, from that 2 squared, plus 27. And then if we want this in our final completed the square form, we want to kind of combine this negative 4 with this positive 27. But all we have to do is remember that that's being multiplied by this 3. So I'd get 3x plus 2 squared minus 4, but remembering that that's multiplied by this 3 here. So minus 12 plus 27, which should give you 3 lots of x plus 2 all squared plus 15. Now, if that's a bit confusing for you, you can of course do it in the way we also used with the negative sign. So we could just take 3 out of the entire expression, so we'd get 3x squared plus 4x plus 9, and leave that all in the brackets, and then complete the square on this entire bracket here. So we'd get 3 lots of x plus 2 squared, taking away our undesired constant, and then adding the constant we want, which is the plus 9, but remembering that's all in one bracket. So 3 lots of x plus 2 squared, and then 9 minus 4 is 5. And then now we can multiply both terms of this bracket 3 by the 3 at the front, so it gets 3 x plus 2 all squared plus 15. Now the last thing I want to just touch on is how we can use completing the square when solving quadratic equations. So you might be asked first to complete the square and then to solve for x. And it's really not too difficult because you actually put it into a very nice form. So 3x plus 2 all squared plus 15. Let's say we actually had that in an equation form. So let's say it was equal to 0. So how then would we solve that for x? And I'm actually going to change it in this case. I'm going to say that, let's say that was negative 15. So what we want to do is essentially rearrange for x. So the first thing we could do is get rid of this constant and move it to the other side. So we'd get 3x plus 2 squared is equal to 15. And then we could divide everything 3 by 3 to get rid of that 3 there. So we'd get x plus 2 squared is equal to 5. Then we could square roots both sides. So we'd get x plus 2 is square root of 5. And remember, when we do a square root in an equation like this, we need to account for the fact that it could have been a negative, as when you square a negative it becomes positive. So we need a plus or minus the square root of 5. And then finally, to solve for x, then we could take 2 from both sides, so we'd get negative 2 plus or minus square root 5.